All right, welcome back, students, as we complete the unit on triangles. This was one bear of a unit, and we're finally getting to the last piece of the puzzle, which is congruence in overlapping triangles. So what are we going to be covering today? We have a few things, and this is arguably the most confusing thing. We're going to talk about common parts of overlapping triangles, using common parts, using two pairs of triangles, separating overlapping triangles, all these things about overlapping triangles, and the way we're going to do it? Proofs! Woo! Yay. Anyway, let's get into the notes. Yay, notes. Here's the only note you gotta know. Triangles can overlap. There's your note. Anyway, seriously, that's the only note. But when we look at triangles that overlap, what is going to be really helpful is to figure out how many triangles do you see. So we take a diagram like this, which is actually going to be used in a proof later on in this video. But how many triangles do you see going on in here? Hopefully you see we have a few triangles. So the first one, that I would point out, do you see the big one, right? ACE, there's that triangle. What about the triangle here, BCE? You see that one, BCE? Like hopefully you see that triangle, right? So you have the big triangle, BCE. With that, hopefully you see ADC, right? You see that triangle as well, right? So you can see that one. What about the skinny ones near the bottom, right? Triangle ADE and triangle EBA, right? And then these little tiny ones, right? DXE and BXA. And the little one at the bottom looks isosceles. Maybe we can't prove it, but AXE. So that's the note. Triangles can overlap. And the challenge is to see all of the different triangles that can make up one diagram of overlapping triangles. And that's going to be the challenge in this entire lesson. And so that's it. Let's just dive into some stuff. First thing we got to cover, though, after the notes, is a thing we call common parts. So a couple of questions here. We're going to talk about common parts of overlapping triangles. Clearly you see the diagram here, and hopefully you can see two triangles overlapping, right? So we got this one with BCE, and then we can have this triangle here with CAD, right? So you can see the two triangles there, they overlap. The question is, what do they have in common? In this question in particular, what angle do they have in common? So when you look at each triangle, what's the angle that they have in common? And hopefully you can see that it is angle C. Angle C is the common angle, and that's just to help us with vocabulary. And even if you were to split the whole thing out, and you were to call it triangle BEC, and then look at the triangle over here where we had triangle CAD, I mean, you can even when you split them out, like you can separate it, you can still see that angle C is the common angle. And so that's what common means. And then a similar question. Here's another diagram with overlapping triangles. What would be the common side in triangle ABD and triangle DCA? And again, you can look at it. If I separate out, let's look at triangle ABD, right? So if we had this triangle and then even label it, right? ABD. And then we separate out the other triangle, DCA. We have D, C, and A. What would be the common side? And hopefully you recognize that they both have segment AD in common, right? So we can have segment AD is the correct response to this, but hopefully you can see that's what common means, and even start thinking now, where might we use something like this in proofs, right? So you can start thinking, where might we use common parts in proofs? And hopefully you are coming to the conclusion this is reflexive property about ready to come, right? So if we have the same thing being shared with two things, you can see the reflexive property is coming. Okay, so I'm gonna talk about that. Reflexive property is coming. Warning, right? So that's a good note to take. So that's the notes, right? The rest, well, let's start jumping in the proofs. Let's do this. Bam. All right, so let me hide a couple things so I can display it in parts, and we'll start with the proof. Here we have a diagram, clearly overlapping triangles. We got some stuff given, and we're going to prove that segment ZW is congruent to segment YX. So we want to look at the end game. We want to look to see, okay, we're going to prove segment ZW is congruent to YX. And we can look at this diagram with overlapping triangles, and one of the things that we can help to do is to split out the triangles. And the reason why is, remember, we have to keep the end game in mind. With common parts, the end game is a little bit challenging. It's really hard to see, because if all we're given is this angle ZXW, right, ZXW, the tiny 3-arc one, so that's 3 arcs, boom, boom, boom. And then we have ZWX, right, so ZWX, ZWX is the big one, right, with 2 arcs, bloop, bloop. That's what we're given. How in the world are we going to prove stuff, right? So how in the world are we going to prove things that are going on? So one of the things I talk about is splitting out the triangles. So if we look here, I'm just going to split out the 2 big triangles. So I'll have WZX and WY, actually XYW if I'm reading it that way. So I have these 2 triangles, and all I'm doing is writing down the congruent statements. So you remember we talked about common parts, and hopefully you can see some common stuff occurring. Now there's also a 3rd triangle with WX and some random point up there, but that's not a very healthy, like, it's not going to get us anywhere. But that is a 3rd triangle, so we're not even going to use it. We're like, all right, fine, we don't even need that one. But it's good to recognize, because sometimes we might, okay? So anyway, we have our 2 triangles here that are split out, and so far what we're given is what I have labeled. So what is the end game going to be? How am I going to show segment ZW, how am I going to show segment ZW congruent to segment YX, right? So we want to keep the end game in mind. How am I going to show those things congruent? And hopefully you can start recognizing some things. We've got a common side. That'll give us angle side angle, right? Angle side angle makes these 2 triangles congruent, and with 2 triangles congruent, corresponding parts of congruent triangles are congruent. Okay, so we can have our end game in mind, but we'll get there. Okay, so we'll take a look. We start with what's given. So what is given? I'm just going to rewrite in bulk the things that are given, right? So I have those given, and then that's why in my diagrams I have my angles labeled. So if that's given, what else can we do? We got to start thinking, and we identify the common side. WX is common, right? So remember the old reflexive property is common. So now we can show that WX is congruent to itself. We now have the reflexive property of congruence. Now here's a helpful tip for you. As we go along, start marking what is congruent. So we've just talked about WX being congruent to itself. Right? So as we looked at our 2 triangles when we separated them out, we can see that they are congruent. And now, what we have now, hopefully you can look here, we now have congruent triangles. Angle side angle congruence, right? So we can talk about that. That's the next thing we can talk about. We now have our 2 triangles congruent by angle side angle. Well, then we're done, right? If we have the 2 triangles congruent, we now have our corresponding parts congruent. So we've proven what we had to prove. Okay, so we now know that ZW is congruent to YX because corresponding parts of congruent triangles are congruent. And that's basically a proof with common parts. It's a proof with overlapping triangles. It's all the same. It's all similar stuff to this. We're just going to have a bunch of overlapping triangles, and things are going to be really tough. So let's do some more more proofs. Yeah. So here's another example, another proof. Right. So we have overlapping triangles clearly. And we have the triangle ACD being congruent to triangle BDC, right? Well, that's a neat thing. So we already know that triangle ACD, this triangle here, is going to be congruent to BDC. Those triangles are congruent. Fantastic. That gives us a lot of information. But the problem is we have to prove CE, just that part, being congruent to DE. Whoa. All right. So that's going to be a little bit tricky. So remember how we figure this out. How many triangles do we see? Hopefully you see 3 triangles. So we have triangle CBD, triangle ACD, and triangle CED. Right? If you see the 3 triangles, we can have an endgame. But what is the endgame? Remember, the endgame is this. I have to prove CE and DE. Right? That's the endgame down there. Man, there's only something we can do. Well, there is. There is something we can do. if these are going to be congruent to one another, right? These are going to be congruent to one another. We have to show that this is an isosceles triangle. So you got to remember that, right? We're going to have to somehow show the end game that this is an isosceles triangle. So if only we can show that this angle C and this angle D are congruent. But where does this angle C come from? Does this angle C come from here? No. This angle C comes from here, okay? So this angle C and this angle C are related. And this angle D doesn't come from up here, it comes from here. So these angle Ds are related. So we can see that, right? You can see where things are coming from. And now, remember these two triangles are congruent. So the angles are congruent because corresponding parts congruent triangles. Two congruent angles gives us two opposite congruent sides. Isosceles definition, there's the end game. Fantastic. So we have it given up. So let's go, right? What's the statement? Let's start with what's given. We have the two triangles congruent. That is our given statement. But what do we do with it? Remember, we can show that these two angles, C and D, are congruent. So if we show that angle BCD, BCD, and angle ADC, ADC, are congruent because corresponding parts of congruent triangles are congruent. Now be careful, we have to label these this way because you can't just call this angle C. It's part of a bigger thing. When I separate it out, yeah, right, it looks like angle C, but when I separate it out, I can do that. If it's all together, I have to name it very carefully. So now I know that these angles are congruent. So I have my angle C and my angle D congruent. So I have my angle C and my angle D congruent. Once I have that congruent, I'm pretty much done. Remember the shortcut from my isosceles triangles. Done. If my base angles are congruent, my opposite sides are congruent. Definition of isosceles triangles. So I've now finished that. Okay, so this proof is done. The hard part is thinking it through, seeing where the angles come from. All right, so overlapping triangles. Let's continue. More crazy stuff. So look at this crazy diagram now. It's getting nuts. E is the midpoint of both AC and DB. Wait, what? What does this even mean? E is the midpoint of AC down here, midpoint, and DB over there, midpoint. Okay, so we got to remember that now. That's going to be an interesting thing. So if that's all we're given, somehow we have to prove that these two triangles, GED, right? You see this triangle? GED and JEB are congruent. So that's going to be a challenge. So let's take a look again. Let's split up the stuff. We see two triangle pairs, right? So I got the big pair up here and the little pair that we're trying to show congruent. And so what do we currently know? Game plan first. Remember that E was the midpoint of AC and DB. And so we knew that AE and CE are congruent, and DB and DE and BE are congruent. And what does that have to do down here? So we know this is congruent to this. Okay, so as we're going along, we can keep track of what's congruent. So all these things, right, are overlapping, and we can keep track of it. So what's the end game? We got to prove these two triangles are congruent. So how are we going to do that? Well, hopefully you see vertical angles in here. We got that. Somehow I got to get to another side, right? Somehow I got to get to something else or even another angle. Maybe I can get to another angle. Man, I don't know, right? Right now I'm lost. I'm not really lost, but right now I'm lost. Let's get started with what we can. So let's go. We have E being the midpoint of AC and DB that's given, right? And so now we have the definition of midpoint establishing our pairs that are like all these tick marks. We got that. Now, what else do we know? We have a couple of vertical angles happening. So let's first look at the big triangle, right? The big triangle. Do you see we have vertical angles in the big triangle? Big vertical angle here, big vertical angle here, which is here and here. Whoa, wait a minute. Something just popped out, right? If I have these two being congruent, then I have my big triangles congruent, side angle side. So if I have side angle side congruence, that's going to be helpful. So let me get there. Right? So I have the big angles, angle AED, and angle CEB are congruent because vertical angles are congruent. I now have side angle side congruence on the big triangles. But the question is, what does that have to do with the triangle I'm trying to prove? Well, if we have our big triangles congruent, that means this angle B is this angle B, right? And this angle D is this angle D. And now, hopefully, the game plan, the end game, is coming alive because now we have an angle, side, angle, and we can establish our triangle congruence. Because now we have, again, the angle here, the side that we've already have, and if we have vertical angles here, now we're proving our triangles. So there's the end game, right? So if that was fast, pause, rewind, or pay attention again. The big triangles are congruent. Big triangle angle, little triangle angle, same angle. Big triangle angle, little triangle angle, same angle. And they are congruent because they're corresponding parts of congruent triangles. So if we establish that as congruent, we now have our vertical angles on the inside, and then we would have our triangles congruent. So let's see what that looks like in the proof. So as we said before, angle D would be congruent to angle B. Corresponding parts of congruent triangles are congruent. Right? Let's keep track of stuff that's going on. Right? So those two are congruent now. And what does that lead us to? That leads us to the two little angles being congruent, the vertical angles, GED. GED is congruent to JEB. Right? So we have those two congruent vertical angles, and now we know angle, actually angle, side angle. I wrote this wrong. Oops. Angle, side angle congruence. Careful, cats. Oh, nuts. So anyway, angle, side, angle congruence. We have now the triangles congruent. And that's that proof. This is fun, right? No, this is hard. I know it's hard. So let's do some more practice. Whee, more proofs. Another proof. So here we go. Given PS is congruent to RS and angle PSQ congruent to angle RSQ, find two triangles, QPT, QRT. What is going on? How many triangles do you see? Well, hopefully you see quite a few. 1, 2, 3, 4, 5, 6 triangles. We're actually not going to use those little ones down there, although we could separate them out. Now we're trying to prove QPT is congruent to QRT. I'm going to separate those out from the big triangles. So this is what I'm going to do. I'm going to separate out my big triangles from my little triangles, and I'm going to copy what I know is true from the given. Okay, so that's all I know. I know these two things. Game plan coming through, right? So hopefully you can see a game plan emerging. If I have this in the big triangle, I got two congruent triangles. If I have two congruent triangles here, I have corresponding parts, right? Look at all these corresponding parts that I would have, an angle and a side here and an angle and a side here. So if I have the two big ones congruent, I have two pieces of the smaller one congruent, reflexive property at the end, side angle side. Bam, right? Done. That's the game plan. That's the hard part. Hard part's over. So let's jump in. So begin with what we always begin with, given stuff, right? PS is congruent to RS, got it. Segment PS congruent to segment RS, got it, right? And angle PSQ is congruent to angle RSQ, got that, that's given, right? So what do we do now? Focusing on the big triangle first. Reflexive property. QS being congruent to itself. So QS is congruent to itself, reflexive property. QS is congruent to itself, reflexive property. And now we can see I have side angle side congruence, I hope. So once we have side angle side congruence, now we have congruent triangles. Now we can use all sorts of corresponding parts. From there, we can say, look at what we can do. Look at this game plan. We can talk about QP being congruent to QR, right? Corresponding parts. And this is the same QP and the same QR, corresponding parts. We can talk about angle PQS and angle RQS congruent, which is the same angles down here. So we have a bunch of stuff ready to emerge. And with that, let's just argue it. So we have our proof. Since we're using the same argument, corresponding parts of congruent triangles are congruent, I group them together. PQ is congruent to RQ, PQ congruent to RQ, and angle SQP congruent to angle SQR. So SQP, SQR, I got the two angles congruent. Now I've established it in the triangle I need to prove. So if I'm proving these two triangles, I'm missing one piece, right? You better see it. You better see it. QT, blam, blam. There it is. So QT, reflexive property, done. There it is. QT, reflexive property, triangles congruent, side angle side. We've got that finished. Okay? Fun stuff, right? If that was too quick, hit pause, rewind, watch it again. See if you can do it on your own. Actually, pause, rewind, try it on your own, then do it. That's going to be even better. Another proof. Remember this from the beginning? Yeah. So now we see a bunch of triangles emerging. So now we have this. We're going to have all this congruent stuff. CA congruent to CE, isosceles. BA congruent to DE, okay, corresponding parts. And then we're going to prove BX and DX. So all this stuff. Look at these triangle pairs. I have the one big triangle. I've got the two smaller triangles and then the two even smaller triangles. So I'm going to look to prove that BX is congruent to DX. So I want to prove BX and DX. This is what I want to prove right here. BX and DX. I got to prove these on the smallest of the triangles. I got to prove them congruent. So let's do what we do. Know what we know. CA congruent to CE. Let's go with the big triangle. CA congruent to CE. We got that big triangle, and that's given, right? So we can start our proof. Now with that, what can we talk about? We can talk about angle A and angle E. And you know where angle A and angle E are the same? They're the same in these two smaller triangles. Angle A and angle E. So let's argue that. CAE is congruent to CEA. That's the definition of isosceles triangles. So what are we going to do with that? Okay. Hopefully what you can see is the other congruence piece. BA being congruent with DE. So where's BA and where's DE? BA is down here. DE is down here. And now that we have that from the given, let's go ahead and establish that was given. Now we can prove these two triangles congruent. Right? Well, that's interesting. How are we going to do that? Reflexive property of AE. Reflexive property of AE, we now have those two triangles congruent, side angle side. And so you might be thinking, Mr. Cass, that has nothing to do with these two triangles. Oh, but it does. Because, remember, BA was congruent to DE, right? And now look at our smallest of the triangles. Look at our smallest of the triangles. The smallest of the triangles is down here. We have this congruent side and this congruent side. We have vertical angles here, but you know what? If these two triangles are congruent, that means that this angle B is congruent to this angle D. And if this angle B and this angle D are congruent, this angle B is the same angle B here. And this angle D is the same angle D here. And now we have angle side congruence of our small triangles and then corresponding parts for the final proof. Okay, so what just happened? Let's walk it through with the proof. So far, where did we leave off? Our two second in size triangles are now congruent, right? So what are we going to do? Let's talk about corresponding parts. Angle ABE and angle ADE are congruent. ABE and ADE are congruent. So we have these two angles congruent. Okay, that's where we're leaving off. What now? Angle BXA is congruent to DXE. BXA, DXE. Vertical angles are congruent. And now the triangles are congruent. Angle, side. Angle, side. Angle, side. So our triangles are congruent. And then we're done. BX and DX, corresponding parts of congruent triangles. All right, so that's how that works. Let me do one more. Right, we'll go a little bit quicker because it's one more, and this one's fun. So this last shape, more overlapping triangles. Holy proofs, cats. So here's what we have. Let's separate out what we know. Right, so I got the two triangles there, the two triangles here. Right, I just wrote them ABE here, right? And then AFC here. Got the two triangles there. I don't think I'm going to use those, actually. And then the diamond triangles, right, in the middle, ABD, and then the two smaller triangles on the edge. Okay, so that's the whole setup. The whole purpose is to prove that BD is congruent to FD. So let's go with what we know. What do we know? We have the given. CAD and EAD are congruent. So we have CAD here and EAD here. Are there any other locations for that angle, right? And the answer is yes. So there's a location down here as well. Okay, so when we have these two triangles, right, so that's congruent, and that's it for that. We also have angle C being congruent to angle E. So we have angle C congruent to angle E. Do those angles show up anywhere else? Yes. Angle C and angle E, and down here as well, angle C and angle E. So we have some stuff, right? And if we're going to prove that BD is congruent to FD, you can almost see the end game. Actually, you see the end game. The end game is there. Take a look. With the two givens that we have, the end game is coming. Okay, and we can see what's going to happen here because we're going to prove these two things are congruent. So let's get there. So I start with what's given, and what's given is just what I marked up, right? The two angles and all the triangles. So what can we establish? We can establish that in the top triangle here, we have an angle and a reflexive property for AD. So let's do that. Let's establish reflexive property of AD. With that, our two triangles are now congruent, ACD and AED. All right, so let's do that. Angle ACD and AED are congruent because of angle side. Now, what are we going to do with that? So take a look at our bottom triangle, the whole thing that's going to wrap this thing up. If we can only show that CD and ED are congruent, we'd have vertical angles here and game over, right? Can we show CD and ED congruent? Yes, we can. If we have CD here and ED here, if we have those, and these two triangles are congruent, corresponding parts, we're all set. So let's go ahead and establish that CD and DE are congruent because of corresponding parts. Right? So that's the whole thing, the whole hiccup. I got these congruent, and they're the same CD and ED down here. So I'm done with all the other triangles. Now I can focus on this one alone, and we're all set. Okay, so I can focus on this triangle alone, and we are all set. Right? Vertical angles in the middle. Boom. Triangles are congruent. Angle, side, angle. Triangles are congruent. Angle, side, angle. And then lastly, BD, FD, corresponding parts. And that is overlapping triangles. Quite frankly, and as you can tell, the most confusing piece of what we've done. But hopefully this is helpful. Practice, practice, practice. And that's it for the unit on triangles. I hope you guys have enjoyed everything. I hope we have... I hope we've learned. All right, that's enough. I'm out. See you for the next unit.